Hey, welcome back everyone. Let's look at another question in Swift. Leetcode 77 combinations. Given two integers n and k, return all possible combinations of k such that their number combinations of k numbers out of range this. So here n is equal to 4, k is equal to 2. Our range would be 1 to 4, and we have to build out all possible combinations of size k. So that means two elements, um, k numbers out of the range 1 to n. Okay, so so since we have to find all the possible combinations, this would again be another backtracking solution. So imagine we are given a range from 1 to 4, right? So 1, 2, 3, 4. So we have to brute force it. So first we pick 1, okay, and then we have three more decisions to make. We have to choose one more number since k is equal to 2. We can choose 1 and three more numbers, 2, 3, 4. That means this would give us 1, 2, 1, 3, and 1, 4, right? We have this over here, this line over here, this 1, 2, 1, 3, 1, 4. That's for 1 here. So again, if we want to not choose 1, if we choose 2, I'm just gonna do it a little bit farther. If we choose 2, um, that's 1, 2, 3, 4. Oh no. If we choose 2, that would be 2, comma 1, 3, 4, right? So that would yield us 2, 1, 2, 3, and 2, 4. But if you notice that all of the results we have already gotten, so we're looking for combinations, not permutations, so we don't really care about the order of things. So we won't be checking any number. If 2 is the root value right now, we won't be checking any value lesser than this. We will only be checking on this side. So if we take all those rules and apply to the same 3, that would mean we only have 4. So that would give us 3 comma 4. And same if we choose 4, there is nothing else, so this won't yield anything. So these 6 are the solution you can see over here. That's how we're going to get the answer, but we will be doing it in a recursive way. So that means we'll have a helper function and resultant value, and we will recursively populate the resultant value. This is how it'll be done on paper, but let's look at the code for this. So we'd require a result variable, which would be of the type this, equals to this, and just simply let's return it to begin with. Okay, and we need another variable temporary which would carry all of the um, all of the paths that we can achieve from a particular node. So if it's 1, 1, 2 is a path, 1, 3 is a path. So at every iteration we would keep track of those paths, and that would be of a array of integers, right? Because like these ones, like I'd be storing this much, right? Okay, So if that makes sense, let's dive in. So we need a helper function called, let's call it backtrack, and let's let it have index for int and a path. This would be in out. So in out allows in out parameters allow you to change an input passed into a function. So if I needed to append something to this, or append something, like suppose we passed result also into this, but I am not. I'm keeping it global. But since if we wanted to append result, so we in result would also be an in out parameter, right? So if that makes sense, this is how you declare an out parameter. This would be exactly as the same as this. We would eventually pass in temp. Yeah. So we have an index parameter and a path parameter, which is in out, which means you can update that within this function. So first we would check if we have k number of characters, which is 2 in this example. So if in the path we have k number of characters, what we do is we update the result with path, right? Like we would update all of, like if at each call site path holds two variables, we would just update add it to the overarching resultant array here. Okay, this is our base case. So let's put down base case. So what are the actions we want to do, right? So we decided that if there is an array 1, 2, 3, 4, we would only check anything that is greater than the current visiting number, right? So the index we are passing will take care of that. So for I in index in a closed range to n, we want the last number 2. In a closed range, we would append this path, like I, because we are adding elements in the path to our result array. Before that, we're adding to the path. And then we would call the backtrack function with updated indexes. So I plus 1. So if we're at 1, if we were at first digit, then we want to continue the backtracking from I plus 1, from 2 onwards. That would be our new start. And the path that we will pass in would be something like this. And that we have passed in the path. This is how you pass in out parameters. Outside also, we can call backtracking. The first element we want to see is 1, because we're going from 1 to n. And temp will be the variable we pass in the in out parameter. And after this line, once this part finishes, we want to remove that path so that we can test out other elements, right? Other digits. So that's all of the action we have to do in the backtracking function. Let's call it action. It can be like it can be multiple actions, but now it's one. And that's all, I think. Let's check. So we declared a result variable depending on this, which would be an array of integers. Then the temp variable, which we want to pass in to carry the path, that is the in out parameter. And we start this helper function. We check our base case, which means like if path dot count is equal to k. So if k is equal to 2, if we have two elements, then we can just simply append it to the path. And then we loop through from index, that's the start, and to n in a closed range, append the index at that point, do the backtracking function, which would check if it's equal to k. If it's not, it would come back here again with an updated index, and then keep adding elements until k is equal, and then it would return multiple times and then come back, and then we would pop that element so we can check for other cases. And this is just a call to the backtrack function, and once this finishes we would have updated results, and that would give us our answer. So let's give this for a spin. Something's wrong. Let's see. Path in out. Int. Oh, so when we append it to result, we also want to return it, right? Since we want to continue with this line again, if this returns only, then we can continue this, right? So that's probably the issue here. Let's run it again. Okay, another issue. I plus 1 path. Okay, so I kind of figured it out. For some reason, this closed range does not work. So we can do n plus 1, and that works, but the closed range doesn't. I'm not sure why, but this essentially means if the range is index is 1 and n is 4, it would give you 1, 2, 3, 4. But so will the closed range from 1 to 4, because that will also give you 1, 2, 3, 4. Just not sure why it doesn't work, but very peculiar. So we can give this a run and it would work. And submit. Yeah, that's it. That's the solution. If you like this and found it educative, please let me know by hitting like and hitting subscribe. I'll be coming up with more videos. See you guys soon.